Welcome to my channel Agentic AI Studio. Today I have brought another video, and it's interesting one about how to think about building real world applications using agent, basically agentic workflows. So there are few videos I have seen where people are talking about it, and it's a new concept, and there are emerging design patterns as well in this field. So today we will look into how do we design, first of all how do we think, and then we will also design one real world use case based on this design. So let's get started. What I'm going to do is, first of all, I will talk about how do we need to go, or what is the approach we need to have before even attempt to build an agent. And that's for a real world scenario. Let's say we want to do a research on certain topic, and we need help of an agent which can do a research on our behalf, either using Google APIs or any third-party APIs, and bring us the data from different sources. Based on our instruction, categorize the data, or I'll say re-rank the data in a manner which is most relevant to my need or to my research requirement. So if we have this particular use case to think and then implement, how will I go about it? So first of all, I'll think as a first step as a goal. So what is my goal? So let me just take one as a step called goal. And next, once I have a goal, what is my natural next step? So I have identified my goal, which means I have identified to build a research agent which can assist me in my research effort. Now that's a goal. I'll also list it here so that we can track the use case along with the design thinking. Research agent. Now this is my goal. What I want to do after that is I want to research it. Basically, the process which I will follow is going to Google or any research engine and start researching for a relevant let's say documents or links or websites, whichever is more appropriate for my research. And for a temporary purpose, we can just assume that we are researching on some generic technology or some tool to study it, how does it work. So we are not going in any specific domain here, but just a general research. So then here I have a desired. So what I will do is, next step is, so the natural next step comes up is the tool to be used for doing my research. So we'll have tool here. Okay, so this is the next step. After this, once I have a research tool available, and for me, we know that I have a Google search engine which I will use manually and manually browse a lot of links to collect the data. And then what is the next step? Once I get the data, what will I do? I will first of all collect the information. So tool, and the next process is collect data. So now we have this tool, and then we will say collect data. So now we have this information so far achieved. So we have done these things. We have goal, we have tool, I'll mention it here, tool, research tool, and then I have a data tool output. So now this is the standard process which I will follow, and once I have the data with me, then what will I do? I will start processing it. Now how do I process it? So I will probably, based on my knowledge, my understanding on a field or a domain, I will find that, okay, what is the relevant information I get from output of the tool? Is it even relevant to my research, or is it not at all relevant, and I need to do further refinement or further research with more search queries? So next step is, let's go to the next step now. So we'll put that. So what we are talking here is the next step is to process the information. Process the data. Okay. Now for a moment just think about it. Processing the data, and we are talking about Google search where you will get a lot of links, lot of documents. Probably if you are searching for some academic documents, PDFs, it's huge. It takes time, and we know the research topic is quite vast. People do research for hours, for days, and don't know, for months as well, depending on which field they are into. But this processing of data is something is manual and takes most of the time for human. Now, when we talk about AI, we need to see where out of these four steps, AI is most helpful. Is it helpful in setting your goal? I think it may or may not be, but most of the time the goal is something which we come up with, what I want to do. And I want to use AI to help me, assist me with a goal, not design the goal, right? So goal, we don't need AI. Next, research tool. We have research tools. So for example, Google research I can use Bing, I can use any other search engine, or if I want to use some kind of API, some API interface, I can use some APIs tools to in a programmatic way. I can write a query, write a program, get the data, call the API, get the data, and then whatever I want to save it, or I want to write some logic to process it. Then the tool output is given to me. After that, the role comes from processing the data, which is generated by the tool. Now this is where the most of the manual effort is going for human, and makes sense to have AI take care of this whole step. Can AI do it or not? That's the question now. So we know that LLM, large language models, are context aware. They can understand the context very well, and some of the large language models even have a longer context window, up to 1 million tokens, like Gemini. For these kind of models, if you give them pages like PDFs, which contains number of pages, maybe 80, 90, or hundreds of pages, as a knowledge base, and ask question or give an instruction, okay, this is what I need, or the kind of information I'm looking to extract from this knowledge base or from this context, then the large language model will do a awesome job of getting the information, provided you have some instructions fine-tuned, means prompting, the way you do prompting. So we have to try it out with a better prompting techniques. But it is possible. Now, if it is possible with large language model, what does it mean? That I, as a human, can outsource this task to AI, because it is going to take lot more my processing power, means my brain or my energy power, my brain power or my energy to process this information. Plus it's manual, so it means I need to spend many hours, lot much time to do it. Whereas LLM can do it in few seconds, irrespective of whatever data you are giving to him. So coming back to this step is something which we can say can it be done by AI or not. So I'll just write it here, AI take over from here. So next, once I have AI, let's say I brought AI here and AI gave me the output. What will I do with the output? Still, as a human, I need to validate the output. I can't just depend on AI's output, because at the end of the day, it's also a computer program or another tool for me. But it's smarter than the other tools. Like search tool will just do search. It will not get the required information based on whatever you need. But LLM is smart enough to figure out based on the context what you need and extract exactly that kind of detail. In fact, the format in which you want, it will give you in that format. So the obvious next step is review. So which is manual. So I will write it here, review of LLM output. Now this is to be done by human or manual process. But what if it can also be done by another LLM? Think about that. If it can be done by another LLM, it means that output, the one which just we got it from this AI step, goes as the input to another LLM, and the instructions will be given differently to this LLM, saying that you are given a output of XYZ agent, which is supposed to do XYZ kind of analysis or research. Check out if it has standard followed, or if it answers these questions appropriately with enough examples, enough details, or in a proper structure. Something like that kind of prompt I can write. If I can do that, then it means this work of review can also be avoided by human. Means, although this is a less manual work, it will not take hours of work for me, but even if it takes some time, few minutes, or maybe let's say half an hour, but that I can also be avoided if I deploy another LLM to review the output of the first LLM or the AI. When I say LLM, is nothing but the AI agent. So here we mention another AI reviews output of first AI task. So we given here we deployed AI, we given a task, okay, take the search data and based on this instruction give me the output. It has done, it did that, let's say it did, and give the output. Now we don't know whether output is appropriate as per my requirement or not. Then I deploy another LLM and say this is the output, this is what it's supposed to do, validate whether it has really done that or not. That's the instruction for this second LLM. Now once we have this, what will happen after this? So the outcome of this is, it will tell, yes, I see the output generated by the system or the another agent or the first agent is as per the standard or as per the instruction which I'm supposed to check, or it is not as per the instruction which I have to follow. It lacks XYZ information, or it lacks proper examples, it lacks enough details on the topic. So what it means, so we will go back, then there will be a loop. Okay, so this we call it as feedback. It means here what is happening, one LLM is generating the output, another LLM is validating the output based on the steps which you would have followed as a reviewer of someone's output, and giving the feedback to the first one, telling this is lacking in your output, go ahead and process it again, or give me the complete information. Let's say it does that few times, 2 times, 3 times, and in few iterations what will happen, the output will be refined from the first AI or the main AI or the agent here. Now if that happens, what we are getting, we are just building an agent and we are asking the agent to reflect its own output and improve till you get the output in a stage where it is acceptable to me, and we have a criteria clearly mentioned in the prompt what is acceptable to me. That's what exactly is the outcome of this. So this review of LLM output, or the agent here, or the LLM AI here, is going to come out of this loop either based on some number of iterations, or if the criteria is fulfilled, whatever we have instructed this LLM to follow. So it means here what will happen, I will have final output here. So if we see here what is happened, now we got a desired output based on what my goal is, and the whole process, setting up the goal, building the agent, assume that you have already this agent built, and getting the desired output is few seconds to few minutes, depending on if you don't like the output, you want to try it again, you want to your research tool is not up to date, or you're not getting enough data and you want to validate what research tool has given as a data to the LLM, and then what LLM has done finally to give you output. So some time is required to review those checkpoints, but in just few minutes you will have your output of the research in front of you in the format which you are looking for. If you want HTML format, if you want just a doc format, if you want markdown format, whatever format you need, it will be there with you. That's the power of, and this is a simple use case where it is only doing the research, means given a problem statement, collect enough information, and from the information which search engine has given to the agent, retrieve or extract based on your instructions, like insights or summarize or key points, whatever that information is given to LLM, and then generate the details in this particular format and make sure that it has properly followed the instruction. That's why we have a reviewer or the self-reflection LLM in place. Now this whole process is called agentic flow, agentic workflow, and we can take this to any level. Think of that, we can have multiple agents deployed doing multiple tasks, and then one agent as a manager collaborating across multiple agents and giving the final output to the user. Because here we have done just one work, which is research and get me the data. What if you want to do a research, then take some action, let's store the data, then after you store the data, you generate some kind of report, means another task. So research, then store, then generate report. So 3 different tasks to be performed by 3 different kind of agents, and probably 3 different tools are required. Here we use for research some research tool or the search API we will be using, but for storing or data in a DB or file system or generating the report, we will have different tools to do it. So these are like arms to LLM which can do the work, give the data to LLM to process it. LLM will come into picture based on the role defined to the given LLM at that point of time. It will perform the role and take the action, and this whole is called agentic workflow. So this is what I wanted to explain, and now we will look into the real world example where we will build the code reviewer, or we can say the someone who can review the code for the peers, or let's say I'm taking an interview and the code submission is done by the interviewee, and I want to have a code review agent to give me the output, in terms of some structure, how the code was written, how well is it readable, is it following the coding standards, what is the performance, does it contain any kind of memory leak or any potential bugs, or how is the overall performance or overall the coding style. So a lot of factors depending on whom I am interviewing or who is my peer for what kind of code review I want to perform. So the use cases could vary in the code review domain itself. But if I have a particular use case defined and I can give an instruction to LLM, then it will give you the required output based on your instruction, and that's what we will see live in this video. Alright, welcome back. So now we will look into the code where I have written a basic code to build a code reviewer agent, and in this code I have already written the script in Python. All I'm going to show you the couple of agent instructions which I was talking in the previous session, and the question which I'll be asking to this agent as a task, because that will be a task for agent, and we'll see the output. How basically focus is to see the output from the agent. Is it doing work as intended, or is it as per my expectation or not? That is overall exercise which we will do. Since this is a real world scenario, a lot of people will require this kind of tool if LLM is able to perform at the level which humans are performing in day-to-day job. So we will check this out in a moment. So here I have a code, and I'll just walk through quickly what I'm done, the description of this video, but right now the focus should be only on the content or the instruction which I am going to walk through, what is going to the agent or the large language model, and how, and then we will see the output, which agent is generating. So here I am saying provide a detailed code review comments for the below mentioned coding assessment. Here is the problem and here is the solution. Okay, so I'm just given a problem and the solution which is given. So it is in this structure which is given. So if you see, it is this is normally we end up seeing a lot of coding assessment at submissions whenever we go for any interviews with the candidates. So this is the input. Now I have a first of all agent here, which is the, I'm calling it a generator. I'm using the reflection part of it which I showed you, so that's why I'm using one generator, means the one which is the prime, whose prime role is to act as a code reviewer. So here I am giving, this is the instruction which I'll just walk the instructions. So I'm saying you are an experienced code reviewer who is tasked to provide a feedback to an interviewee on his or her submitted coding assignment. Then this is a task. Your goal is to write well-structured, detailed code review for the submitted code, and subtasks are here. So I'm saying you will generate a document called code review comments for the submitted code and send it to your manager for review. Now, why did I use the word manager? Because I'm here trying to create couple of rules. I don't want just agent or this particular LLM to generate the output and I should be validating the output. I am deploying another agent, which is the role of that agent is a manager of this agent. So here this LLM will act as a code reviewer, and another LLM will act as a manager of code reviewer. So I'll walk the instructions quick, once we go to the reflector. And these are instructions, and that's giving that I need the output in this particular format: code review comments, assignment name, candidate name. Although I'm not given the candidate name, but it's fine. This we can even fill up. But main thing is this is structure I'm looking for: overview, general observation, briefly summarize the overall impression of the code, highlighting major strengths and weaknesses. And that's how we would want to, right? In general, but there could be, as I mentioned, there could be cases where you are doing a peer review and that code is very complex or very specific to the particular domain or a product in which you are working, and you want different instructions to be given as an output from LLM. So you can just change this instruction. So since this is the use case where I'm taking the interview and that interviewee's submission, I'm submitting it here and I'm asking, I want this code review to be done at these parameters, like code quality, coding standards, potential issues, and then giving the instructions for each setting, performance, improvements. So these are my parameters, and this is structure. So that's it, nothing else. Next I go to reflector, and the instruction for the reflector is you are a manager of a product engineering team, and one of your responsibilities to review the code review document written by your team member. And your goal is to critique the code review comments written by your team member and push him or her, to improve the quality of the code review process. Next, subtask. Evaluate your team member code review comments against the following standards. So I'm giving the clear instruction, what you need to validate. It means if I would be getting the output from the LLM, what I would be doing, I would be checking, okay, whether this AI tool has checked if the code is working or not working, if the proper syntax is used or not, or coding standards are followed or not, is there any bug in or any edge cases are missed, or the memory leaks are happening or not. That's what I'm just giving few of the instructions, and this could be as detailed as you want. Did he capture notes about the correctness of the code syntax? Did he check if the submitted code contain complete implementation of the given assessment by running it locally, and all these instructions? Then I'm saying based on the basically your finding, you will take one of the below action. If you find that comments are fully incorporated and you do not have any more comments to provide, then approve it and ask your team member to share it, or else you send your finding to him to incorporate in his code review document. That's all I'm done with this. So here is the input, and let's start. And I'm using I'm going to use GPT-4 here, this model. Reason being, I tried GPT-3, Gemini. They are not at par with understanding this agentic workflow, where you are going to have a kind of conversation and where instructions are strictly followed. Because here what will happen is, first agent will create the output in the format. Then another agent, which is actually a manager or reflector, is supposed to give a feedback on it. And once it has the feedback given, then this agent, first agent, is supposed to, or the code reviewer is supposed to incorporate the feedback and generate another version of the code review comments. So let me do one thing. I will have an iteration set. Basically, we can hard code the iterations. So I will just make it 4. I'll check that there are 2, and after 2 iterations, mostly it should be okay. Or I can have 1 iteration. Let me just do a 1 iteration. Sorry, 2. So 1 iteration means I will have a agent, code review agent, giving the output. Then the reviewer will provide a feedback on the output, and code reviewer agent will take the output and come up with a revised version of it. That's like one loop. So that's what I call it as the end after 1 iteration. But we can go to 2-3 iterations depending on how the model performance or how the prompts are written. There are a lot of factors basically. These are all configurable based on the use cases. Now I go ahead and run it. So py reflection today. So we'll just wait and see the output and go to the output after the output is there. But I will wait for it and then we'll go from there. Okay, let's go here. We got the complete output. So this is where I started. So first of all, it generated, means the agent which is code reviewer, it generated the code review comment document and mentioned balancing parentheses and infix expression, because that was a problem statement. So left parentheses were missing, right parentheses were there, and the goal was to come up with the algorithm which can identify the places where to put the left parentheses and balance it. Balance the infix expression. Okay, so let's see first of all, it has followed the format properly. I can show you what did I give as instruction to this, then we can validate the format. So this was my instruction to follow this output format: overview, detailed feedback, code quality. So let's check it out. Do we have an overview? Yes, we have a general observation. Exactly as the same thing. The provided solution attempts to balance missing left parenthesis in an infix expression using 2-stack. The approach is creative, but implementation is complex and difficult to follow due to lack of commands and unclear variable naming. So this is a summary. The code does not meet the expected output as per the problem statement. Functionality. What did I ask? State whether the code fulfills the assignment requirements and expected output. The code does not correctly balance the parentheses as required. The expected output for the given input does not match the actual output produced by the program. Fine. Next. Detailed feedback. Now this is summary. Fine. So we got it at least. Okay. The code which is submitted, is it even done at expectation or not done at the expectation level? Now let's see the details, and that's what I asked here. Code quality, coding standards. So code quality, the code is hard to read and understand. Variable names like S1, S3, X1 and Y are not descriptive, making it difficult to understand their purpose at a glance. There is a significant lack of comments in the code which makes it challenging to follow the logic. Then we have I'll just continue from top. Okay, then we see the potential coding standards. Code does not adhere to commons, because this code was submitted in C++ language, so it does not adhere to common C++ coding standards. For instance, variable names should be more descriptive and use of excessive global include statement should be minimized. Okay, so this is a good, I think it followed the format properly. I can just say potential issues, and then we can see what are the issues it mentioned. It talked about the code does not handle edge cases well. For example, there are no checks for empty strings or strings without any parentheses. Performance and improvement. So here are the improvements suggested. Refactor the code into smaller functions to handle specific tasks, such as parsing the input, inserting parentheses and all. So I think I feel the feedback, what it has come up is good. The code review comments are good. Now let's see what is the reflection this agent has done. So we deployed the reflector, basically manager, who will see this feedback and try to who will see the code reviews comments and try to give a feedback. And here is the output. Thank you for providing the code review document. Here are some suggestions to enhance the quality of your review process. So it is talking to the agent, which is a code reviewer, and this reflector is the manager. First of all, correctness of the code syntax. Your review briefly mentions variable namings and modularity, but does not explicitly address the correctness of the syntax, such as proper use of loops, conditions, or function calls. Next, complete implementation check. The review does not mention whether the code was executed to verify its functionality in case the problem. It is crucial to run the code because it just mentioned on the top in general that the output is not expected. Output is not as per the expected or a desired output. But it should mention clearly, I tried to run, I got this error or some compilation error, something like that. Identification of potential bug. While you noted the logic errors and potential issues with edge cases, calling out specific potential bugs like memory leaks, infinite loops, and conditions that could lead to unexpected behavior would strengthen the review. Okay, so I think it has given the feedback. Now it's saying the action required. Please incorporate these points into your code review document to provide a more thorough and actionable feedback for the developer, for which code reviewer is doing the code review. This will not only help in enhancing the current solution, but also aid in the professional growth of developer by highlighting critical areas of improvement. Now let's see what it does. Now it comes with the code review comments again. I think another version generate. So general observation, problem solution attempts to balancing this. The approach is creative, but implementation is complex and difficult to follow. The code does not meet the expected output problem. The code does not functionality. Fine. Again, I think same output which I see. The code is hard to read. I think this is again same. So coding standards, code does not adhere to this. For instance, variables should be more descriptive. Then potential errors, logic to balance this is flawed. Program does not quickly identify where to insert left to balance an expression properly. Code does not handle edge cases well. For example, there are no checks for empty strings and strings without parentheses. Now there's no error handling to manage incorrect inputs and other runtime errors. So this is what we see. Let's check that the original document what it produced and the one which we see right now, is it different from the first one? So we'll go to this section called potential issues and bugs and validate. So potential issues and bugs. So I think there were edge cases they mentioned. Okay, the logic errors, it was also mentioned. Error handling, there is no error handling to manage incorrect inputs, and memory leaks, there is no evidence of memory leaks and overall management. So 4 sections were there, but with the new one we have syntax and correctness also added. The code contains several syntax errors and improper use of loops and condition, because in the feedback it was mentioned you should also talk about loops, condition, function calls. For instance, the loop of popping from this is overly complex and prone to errors. Proper input validation is absent, which could lead to runtime errors if the input is not as expected. So I see. So it means it was able to understand that whatever it has done and whatever was the feedback, it just incorporated the feedback. Here we see the example of it under the potential issues and bugs section. So this is what it means. So as I said, the first version to me looked great. The first output of the agent looked to be great. It looks like a very extensive and detailed code review document. But when we put it for reflection or when we put it for feedback to another LLM can add, give a very pointed kind of feedback, and then this LLM, which is a primary agent, can incorporate it and make it exhaustive list of comments or whatever expected output you have looking from the agent. So this is what I wanted to show you, and this is made possible only with GPT-4. I tried Gemini, I tried GPT 3.5. None of those models were close to this kind of output. So that's why I think for agentic workflow, till other models are improving their reasoning capability or understanding the agentic flow better, which I know they require some kind of fine-tuning the model once they have this newer latest releases happening for any big LLM, they need to make sure that they are also kind of accurate for the agentic tasks. So I'm sure that if I put Gemini for just doing the code review, which means no reflection, then it will also it would be able to do it decent job, means to follow the standards, whatever I asked in the prompt. But then coming the feedback and fill only on those areas which are not properly addressed, not like rewriting the whole feedback again and changing the points altogether. No, still remembering that these are the points which I given earlier, and these were the pointed queries or the feedback on certain sections I need to take and incorporate, and wherever it felt relevant, it incorporated. That is what I see as a real use case, the very useful use case for those who want to engage agents in the field of code review, or in the field of interviewing or reviewing people who are submitting the code. And today we have just a rule-based system, like a online system, which is which can just give some generic output, but here you have a pointed output, and it also helps us evaluate interviewee or candidates thinking, how good or how smart the person is while while the person is going for a technical rounds. So I feel that this is the power we should use for LLM. Basically, the better prompting techniques, better models will give us better output, and day by day other models are also going to improve. And the last part which I want to talk about is the cost. We all know that GPT 4.0 is or GPT-4 to be precise, is costliest model as of today. But the primary thing is, if I'm not able to serve the output or accurate output, if I'm not getting, then there's no point of me using any model. It means I can't even serve the use case. Yes, the cost is a major factor, so it means I can evaluate for my use case if these many resources I'm deploying, or number of hours are spent by one person to do X kind of work, or XYZ task. Now same task, if I offload and get it done by agent, what is the benefit I have? How much money I'm saving? I mean, we can have that kind of analysis done at use case by use case, and I think we can come with a better approach to use models. And we can also use combination of models, by the way. It's not like you have to always use GPT-4 for all the AI calls. Here we needed to, because we are just having both sides strong, like a manager and the agent reviewer. But in some cases, we don't need heavy model like GPT-4 to execute the task. For example, given a basic instruction, call XYZ API, get the data and format it in this particular structure. That can be done by any model, even the cheapest model like GPT-3 or the open source model as well. So we have to analyze our use case properly before we deploy these LLMs or for building the agents. So that's all I wanted to share insights. Whenever we're going for real world use case, a lot of factors are there to make things happen accurately, performant, fast, but everything is possible only once we try out these combinations, or we follow some kind of a structure thinking, design thinking into the building of agent applications. That's all, and thanks. See you next time.